We're reading a discourse written by George Berkeley entitled The Analyst. Runs about 34 pages. The Analyst, a discourse addressed to an infidel mathematician, written by George Berkeley, published in the United States of America by the Library of Alexandria. The Analyst, or a discourse addressed to an infidel mathematician, wherein it is examined whether the object, principles, and inferences of the modern analysis are more distinctly conceived or more evidently deduced than religious mysteries and points of faith, by the author of the Minute Philosopher, or the Minute Philosopher. First, cast out the beam out of thine own eye, and then shalt thou see clearly to cast out the mote out of thy brother's eye. Matthew chapter 7, verse 5. Section 1. I, though I am a stranger to your person, yet I am not, sir, a stranger to the reputation you have acquired in that branch of learning which hath been your peculiar study, nor to the authority that you therefore assume in things foreign to your profession, nor to the abuse that you, and too many more of the like charader, are known to make of such undue authority, to the misleading of unwary persons in matters of the highest concern, and whereof your mathematical knowledge can by no means qualify you to be a competent judge. Equity, indeed, and good sense would incline one to disregard the judgment of men in points which they have not considered or examined. But several who make the loudest claim to those qualities do, nevertheless, the very thing they would seem to despise, clothing themselves in the livery of other men's opinions, and putting on a general deference for the judgment of you, gentlemen, who are presumed to be of all men the greatest masters of reason, to be the most conversant about distinct ideas, and never to take things upon trust, but always clearly to see your way as men whose constant employment is the deducing truth by the justest inference from the most evident principles. With this bias on their minds, they submit to your decisions where you have no right to decide. And this is one short way of making infidels incredibly informed. Section 2. Whereas then it is supposed that you apprehend more distinctly, consider more closely, infer more justly, conclude more accurately than other men, and that you are therefore less religious because more judicious, I shall claim the privilege of a free thinker, and take the liberty to inquire into the object, principles, and method of demonstration admitted by the mathematicians of the present age, with the same freedom that you presume to treat the principles and mysteries of religion, to the end that all men may see what right you have to lead, or what encouragement others have to follow you. It hath been an older remark that geometry is an excellent logic, and it must be owned that when the definitions are clear, when the postulates cannot be refused, nor the axioms denied, when from the distinct contemplation and comparison of figures their properties are derived by a perpetual well-connected chain of consequences, the objects being still kept in view, and the attention ever fixed upon them, there is acquired an habit of reasoning, close and exact and methodical, which habit strengthens and sharpens the mind, and being transferred to other subjects, is of general use in the inquiry after truth. But how far is this the case of our geometrical analysts? It may be worthwhile to consider. Section 3. The method of fluxions is the general key, by help whereof the modern mathematicians unlock the secrets of geometry and consequently of nature. And as it is, that which hath enabled them so remarkably to outgo the ancients in discovering theorems and solving problems, the exercise and application thereof is become the main, if not sole, employment of all those who in this age pass for profound geometers. But whether this method be clear or obscure, consistent or repugnant, demonstrative or precarious, as I shall inquire with the utmost impartiality, so I submit my inquiry to your own judgment and that of every candid reader. Lines are supposed to be generated by the motion of points, planes by the motion of lines, and solids by the motion of planes. And whereas quantities generated in equal times are greater or lesser, according to the greater or lesser velocity wherewith they increase and are generated, a method hath been found to determine quantities from the velocities of their generating motions. And such velocities are called fluxions, and the quantities generated are called flowing quantities. These fluxions are said to be nearly as the increments of the flowing quantities generated in the least equal particles of time, and to be accurately in the first proportion of the nascent, or in the last of the evanescent. Increments. Sometimes, instead of velocities, the momentaneous increments or decrements of undetermined flowing quantities are considered under the appellation of moments. Section 4. By moments, we are not to understand finite particles. These are said not to be moments, but quantities generated from moments, which last are only the nascent principles of infinite quantities. It is said that the minutest errors are not to be neglected in mathematics, that the fluxions are celerities, not proportional to the finite increments, though ever so small, but only to the moments or nascent increments, whereof the proportion alone and not the magnitude is considered. And of the aforesaid fluxions, there be other fluxions, which fluxions of fluxions are called second fluxions. And the fluxions of these second fluxions are called third fluxions, and soon fourth, fifth, sixth, and ad infinitum. Now, as our sense is strained and puzzled with the perception of objects extremely minute, even so the imagination, which faculty derives from sense, is very much strained and puzzled to frame clear ideas of the least particles of time, or the least increments generated therein, and much more so to comprehend the moments, or those increments of the flowing quantities in statu nascinti, in their very first origin or beginning to exist, before they become finite particles. And it seems still more difficult to conceive the abstracted velocities of such nascent and perfect entities. But the velocities of the velocities, the second, third, fourth, and fifth velocities, etc., exceed, if I mistake not, all humane understanding. The further the mind analyzeth and pursueth these fugitive ideas, the more it is lost and bewildered. The objects, at first fleeting and minute, soon vanishing out of sight, Certainly, in any sense, a second or third fluxion seems an obscure mystery. The incipient celerity of an incipient celerity, the nascent augment of a nascent augment, an example of a thing which hath no magnitude. Take it in which light you please. The clear conception of it will, if I mistake not, be found impossible. Whether it be so or no, I appeal to the trial of every thinking reader. And if a second fluxion be inconceivable, what are we to think of third, fourth, fifth fluxions, and so onward without end? Section 5. The foreign mathematicians are supposed by some, even of our own, to proceed in a manner less accurate perhaps in geometrical, yet more intelligible. Instead of flowing quantities in their fluxions, they consider the variable finite quantities as increasing or diminishing by the continual addition or subduction of infinitely small quantities. Instead of the velocities wherewith increments are generated, they consider the increments or decrements themselves, which they call differences and which are supposed to be infinitely small. The difference of a line is an infinitely little line, of a plane an infinitely little plane. They suppose finite quantities to consist of parts infinitely little, and curves to be polygons, whereof the sides are infinitely little, which by the angles they make one with another determine the curvity of the line. Now, to conceive a quantity infinitely small, that is, infinitely less than any sensible or imaginable quantity, or that than any the least finite magnitude, is, I confess, above my capacity. But to conceive a part of such infinitely small quantity, that shall be still infinitely less than it, and consequently, though multiplied infinitely, shall never equal the minutest finite quantity, is, I suspect, an infinite difficulty to any man whatsoever, and will be allowed such by those who candidly say what they think, provided they really think and reflect and do not take things upon trust. Section 6. And yet, in the calculus differentialis, which method serves to all the same intents and ends with that of fluxions, our modern analysts are not content to consider only the differences of finite quantities. They also consider the differences of those differences, and the differences of the differences of the first differences, and so on ad infinitum. That is, they consider quantities infinitely less than the least discernible quantity, and others infinitely less than those infinitely small ones, and still others infinitely less than the preceding infinitesimals, and so on without end per limit. And so much that we are to admit an infinite succession of infinitesimals, each infinitely less than the foregoing and infinitely greater than the following. As there are first, second, third, fourth, fifth, and so on fluxions, so there are differences, first, second, third, fourth, fifth, in an infinite progression towards nothing, which you still approach and never arrive at, and which is most strange. Although you should take a million of millions of these infinitesimals, each whereof is supposedly infinitely greater than some other real magnitude, and add them to the least given quantity, it shall never be the bigger. For this is one of the modest postulata of our modern mathematicians, and is a cornerstone or groundwork of their speculations. Section 7. All these points, I say, are supposed and believed by certain rigorous exactors of evidence in religion, men who pretend to believe no further than they can see, that men who have been conversant only about clear points should with difficulty admit obscure ones might not seem altogether unaccountable. But he who can digest a second or third fluxion, a second or third difference, need not, methinks, be squeamish about any point in divinity, there is a natural presumption that men's faculties are made alike. It is on this supposition that they attempt to argue and convince one another. What, therefore, shall appear evidently impossible and repugnant to one may be presumed the same to another. But with what appearance of reason shall any man presume to say that mysteries may not be objects of faith, at the same time that he himself admits such obscure mysteries to be the object of science? Section 8. It must indeed be acknowledged, the modern mathematicians do not consider these points as mysteries, but as clearly conceived and mastered by their comprehensive minds. They scruple not to say that by the help of these new analytics, they can penetrate into infinity itself, that they can even extend their views beyond infinity, that their art comprehends not only infinite, but infinite of infinites, as they express it, or an infinity of infinites. But notwithstanding all these assertions and pretensions, it may be justly questioned whether, as other men and other inquiries are often deceived by words or terms, so they likewise are not wonderfully deceived and deluded by their own peculiar signs, symbols, or species. Nothing is easier than to devise expressions or notations for fluxions and infinitesimals of the first, second, third, fourth, and subsequent orders, proceeding in the same regular form without end or limit. And these expressions indeed are clear and distinct, and the mind finds no difficulty in conceiving them to be continued beyond any assignable bounds. But if we remove the veil and look underneath, if laying aside the expressions, we set ourselves attentively to consider the things themselves, which are supposed to be expressed or marked thereby, we shall discover much emptiness, darkness, and confusion. Nay, if I mistake not, direct impossibilities and contradictions. Whether this be the case or no, every thinking reader is entreated to examine and judge for himself. Section 9. Having considered the object, I proceed to consider the principles of this new analysis by momentums, fluxions, or infinitesimals, wherein if it shall appear that your capital points, upon which the rest are supposed to depend, include error and false reasoning, it will then follow that you, who are at a loss to conduct yourselves, cannot with any decency set up for guides to other men. The main point in the method of fluxions is to obtain the fluxion or momentum of the rectangle or product of two indeterminate quantities, inasmuch as from thence are derived rules for obtaining reflections of all other products and powers, be the coefficients or the indexes what they will, integers or fractions, rational or surd. Now, this fundamental point, one would think, should be very clearly made out, considering how much is built upon it, and that its influence extends throughout the whole analysis. But let the reader judge. This is given for demonstration. Suppose the product, a rectangle, AB, increased its continual motion, and that the momentaneous increments of the sides A and B are A and B. When the sides A and B were deficient or lesser by 1/2 of their moments, the rectangle was A minus 1/2 A times B minus 1/2 B. An example, AB minus 1/2 AB minus 1/2 BA plus 1/4 AB. And as soon as the sides A and B are increased by the other 2 halves of their moments, the rectangle becomes A plus 1/2 A times B plus 1/2 B, or AB plus 1/2 AB plus 1/2 A plus 1/4 AB. From the latter rectangle, subduct the former, and the remaining difference will be AB plus BA. Therefore, the increment of the rectangle generated by the entire increments A and B is AB plus BA. But it is plain that the direct and true method to obtain the moment or increment of the rectangle AB is to take the sides as increased by their whole increments, and so multiply them together. A plus A by B plus B, the product whereof AB plus AB plus BA plus AB is the augmented rectangle, whence if we subduct AB, the remainder AB plus BA plus AB will be the true increment of the rectangle, exceeding that which was obtained by the former illegitimate and indirect method by the quantity AB. And this holds universally, be the quantities A and B what they will, big or little, finite or infinitesimal, increments, moments, or velocities. Nor will it avail to say that AB is a quantity exceeding small, since we are told that in rebus mathematicus errores quam minimi non sunt contemendi. Such reasoning as this for demonstration, nothing but the obscurity of the subject could have encouraged or induced the great author of the fluxionary method to put upon his followers, and nothing but an implicit deference to authority could move them to admit. The case, indeed, is difficult. There can be nothing done till you have got rid of the quantity AB. In order to this, the notion of fluxions is shifted. It is placed in various lights. Points which should be clear as first principles are puzzled, and terms which should be steadily used are ambiguous. But notwithstanding all this, address and skill, the point of getting rid of AB cannot be obtained by legitimate reason. If a man by methods, not geometrical or demonstrative, shall have satisfied himself of the usefulness of certain rules which he afterwards shall propose to his disciples for undoubted truths, which he undertakes to demonstrate in a subtle manner by the help of nice and intricate notions, it is not hard to conceive that such his disciples may, to save themselves the trouble of thinking, be inclined to confound the usefulness of a rule with the certainty of a truth, and accept the one for the other, especially if they are men accustomed rather to compute than to think, earnest rather to go on fast and far, than solicitous to set out warily and see their way distinctly. Section 11. The points or mere limits of nascent lines are undoubtedly equal, as having no more magnitude one than another, a limit as such being no quantity. If by a momentum you mean more than the very initial limit, it must be either a finite quantity or an infinitesimal. But all finite quantities are expressly excluded from the notion of a momentum. Therefore, the momentum must be an infinitesimal. And indeed, though much artifice hath been employed to escape or avoid the admission of quantities infinitely small, yet it seems ineffectual. For aught I see, you can admit no quantity as a medium between a finite quantity and nothing, without admitting infinitesimals. An increment generated in a finite particle of time is itself a finite particle and cannot therefore be a momentum. You must therefore take an infinitesimal part of time wherein you generate your momentum. It is said the magnitude of moments is not considered, and yet these same moments are supposed to be divided into parts. This is not easy to conceive, no more than it is why we should take quantities less than A and B in order to obtain the increment of AB, of which proceeding it must be owned the final cause or motive is very obvious. But it is not so obvious or easy to explain a just and legitimate reason for it, or shew it to be geometrical. Section 12. From the foregoing principles so demonstrated, the general rule for finding the fluxion of any power of a flowing quantity is derived. But, as there seems to have been some inward scruple or consciousness of defect in the foregoing demonstration, and as this finding the fluxion of a given power is a point of primary importance, it hath therefore been judged proper to demonstrate the same in a different manner, independent of the foregoing demonstration. But whether this other method be more legitimate and conclusive than the former, I proceed now to examine, and in order thereto shall premise the following lemma. If, with a view to demonstrate any proposition, a certain point is supposed, by virtue of which certain other points are attained, and such supposed point be it self afterwards destroyed or rejected by a contrary supposition. In that case, all other points attained thereby and consequent thereupon must also be destroyed and rejected, so as from thenceforward to be no more supposed or applied in the demonstration. This is so plain as to need no proof. Section 13. Now, the other method of obtaining a rule to find the fluxion of any power is as follows. Let the quantity x flow uniformly, and be it proposed to find the fluxion of x to the n power. In the same time that x by flowing becomes x plus o, the power x raised to the nth power becomes x plus the method of infinite series, and the increments are to one another as xn plus noxn minus 1 plus nm minus n ooxn minus 2 plus c2. O and noxn minus 1 plus nn minus n ooxn minus 2 plus c2. 1 to nxn minus 1 plus nn minus noxn minus 2 plus c2. Let now the increments vanish, and their last proportion will be 1 to nxn minus 1. But it should seem that this reasoning is not fair or conclusive. For when it is said, let the increments vanish, in example, let the increments be nothing, or let there be no increments, the former supposition that the increments were something, or that there were increments, is destroyed, and yet a consequence of that supposition, an example, an expression got by virtue thereof is retained, which by the foregoing lemma is a false way of reasoning. Certainly, when we suppose the increments to vanish, we must suppose their proportions, their expressions, and everything else derived from the supposition of their existence to vanish with them. You may possibly hope to evade the force of all that hath been said, and to screen false principles and inconsistent reasoning by a general pretense that these objections and remarks are metaphysical. But this is a vain pretense. For the plain sense and truth of what is advanced in the foregoing remarks, I appeal to the understanding of every unprejudiced, intelligent reader. To the same I appeal whether the points remarked upon are not most incomprehensible metaphysics, and metaphysics not of mine, but your own. I would not be understood to infer that your notions are false or vain because they are metaphysical. Nothing is either true or false for that reason. Whether a point be called metaphysical or not avails little. The question is whether it be clear or obscure, right or wrong, well or ill deduced. Although momentaneous increments, nascent and evanescent quantities, fluxions of infinitesimals of all degrees, are in truth such shadowy entities, so difficult to imagine or conceive distinctly, that, to say the least, they cannot be admitted as principles or objects of clear and accurate science. And although this obscurity and incomprehensibility to your metaphysics has been alone sufficient to allay your pretensions to evidence, yet it hath, if I mistake not, been further shown that your inferences are no more just than your conceptions are clear, and that your logics are as exceptionable as your metaphysics. Should seem, therefore, upon the whole, that your conclusions are not attained by just reasoning from clear principles. Consequently, that the employment of modern analysts, however useful in mathematical calculations and constructions, doth not habituate and qualify the mind to apprehend clearly and infer justly, and consequently that you have no right, in virtue of such habits, to dictate out of your proper sphere, beyond which your judgment is to pass for no more than that of other men. Of a long time I have suspected that these modern analytics were not scientifical, and gave some hints thereof to the public about 25 years ago, since which time I have been diverted by other occupations, and imagined I might employ myself better than in deducing and laying together my thoughts on so nice a subject. And though of late I have been called upon to make good my suggestions, yet as the person who made this call doth not appear to think maturely enough to understand either those metaphysics which he would refute or mathematics which he would patronize, I should have spared myself the trouble of writing for his conviction. Nor should I now have troubled you or myself with this address, after so long an intermission of these studies, were it not to prevent, so far as I am able, your imposing on yourself and others in matters of much higher moment and concern, and to the end that you may more clearly comprehend the force and design of the foregoing remarks, and pursue them still further in your own meditations, I shall subjoin the following queries. Query 1. Whether the object of geometry be not the proportions of assignable extensions, and whether there be any need of considering quantities either infinitely great or infinitely small. 2. Whether the end of geometry be not to measure assignable finite extension, and whether this practical view did not first put men on the study of geometry. 3. Whether the mistaking the object and end of geometry hath not created needless difficulties and wrong pursuits in that science. 4. Whether men may properly be said to proceed in a scientific method without clearly conceiving the object they are conversant about, the end proposed, and the method by which it is pursued. 5. Whether it doth not suffice that every assignable number of parts may be contained in some assignable magnitude, and whether it be not unnecessary as well as absurd to suppose that finite extension is infinitely divisible. 6. Whether the diagrams in a geometrical demonstration are not to be considered as signs of all possible finite figures, of all sensible and imaginable extensions or magnitudes of the same kind. 7. Whether it be possible to free geometry from insuperable difficulties and absurdities, so long as either the abstract general idea of extension or absolute external extension be supposed its true object. 8. Whether the notions of absolute time, absolute place, and absolute motion be not most abstractedly metaphysical, whether it be possible for us to measure, compute, or know them. 9. Whether mathematicians do not engage themselves in disputes and paradoxes concerning what they neither do nor can conceive, and whether the doctrine of forces be not a sufficient proof of this. 10. Whether in geometry it may not suffice to consider assignable finite magnitude without concerning ourselves with infinity, and whether it would not be righter to measure large polygons having finite sides instead of curves, and to suppose curves are polygons of infinitesimal sides, a supposition neither true nor conceivable. 11. Whether many points which are not readily assented to are not nevertheless true, and whether those in the two following queries may not be of that number. 12. Whether it be possible that we should have had an idea or notion of extension prior to motion, or whether if a man had never perceived motion, he would ever have known or conceived one thing to be distant from another. 13. Whether geometrical quantity hath coexistent parts, and whether all quantity be not in a flux as well as time and motion. 14. Whether extension can be supposed an attribute of a being immutable and eternal. 15. Whether to decline examining the principles and unraveling the methods used in mathematics would not shew a bigotry in mathematicians. 16. Whether certain maxims do not pass current among analysts, which are shocking to good sense, and whether the common assumption that a finite quantity divided by nothing is infinite be not of this number. 17. Whether the considering geometrical diagrams absolutely or in themselves, rather than as representatives of all assignable magnitudes or figures of the same kind, be not a principal cause of the supporting finite extension infinitely divisible, and of all the difficulties and absurdities consequent thereupon. 18. Whether from geometrical propositions being general, and the lines in diagrams being therefore general substitutes or representatives, it doth not follow that we may not limit or consider the number of parts, into which such particular lines are divisible. 19. When it is said or implied that such a certain line delineated on paper contains more than any assignable number of parts, whether any more in truth ought to be understood than that it is a sign indifferently representing all finite lines, be they ever so great, in which relative capacity it contains, an example, stands for more than any assignable number of parts, and whether it be not altogether absurd to suppose a finite line, considered in itself or in its own positive nature, should contain an infinite number of parts. 20. Whether all arguments for the infinite divisibility of finite extension do not suppose and imply either general abstract ideas or absolute external extension to be the object of geometry, and therefore whether along with those suppositions such arguments also do not cease and vanish. 21. Whether the supposed infinite divisibility of finite extension have not been a snare to mathematicians and a thorn in their sides, and whether a quantity infinitely diminished and a quantity infinitely small are not the same thing. 22. Whether it be necessary to consider velocities of nascent or evanescent quantities, or moments, or infinitesimals, and whether the introducing of things so inconceivable would be not a reproach to mathematics. 23. Whether inconsistencies can be truths, whether points repugnant and absurd are to be admitted upon any subject or in any science, and whether the use of infinites ought to be allowed as a sufficient pretext and apology for the admitting of such points in geometry. 24. Whether a quantity be not properly said to be known, when we know its proportion to given quantities, and whether this proportion can be known but by expressions or exponents, either geometrical, algebraical, or arithmetical, and whether expressions in lines or species can be useful but so far forth as they are reducible to numbers. 25. Whether the finding out proper expressions or notations of quantity be not the most general character and tendency of the mathematics, and arithmetical operation that which limits and defines their use. 26. whether mathematicians have sufficiently considered the analogy and use of signs, and how far the specified limited nature of things corresponds thereto. 27. Whether because, in stating a general case of pure algebra, we are at full liberty to make a character denote either a positive or a negative quantity, or nothing at all. We may therefore, in a geometrical case, limited by hypotheses and reasonings from particular properties and relations of figures, claim the same license. 28. Whether the shifting of the hypothesis, or, as we may call it, the fallacia suppositionis, be not a sophism that far and wide infects the modern reasonings, both in the mechanical philosophy and in the abstruse and fine geometry. 29. Whether we can form an idea or notion of velocity distinct from and exclusive of its measures, as we can of heat distinct from and exclusive of the degrees on the thermometer by which it is measured, and whether this be not supposed in the reasonings of modern analysts. 30. Whether motion can be conceived in a point of space, and if motion cannot, whether velocity can, and if not, whether a first or last velocity can be conceived in a near limit, either initial or final, of the described space. 31. Where there are no increments, whether there be any ratio of increments, whether nothings can be considered as proportional to real quantities, or whether to talk of their proportions be not to talk nonsense. Also, in what sense we are to understand the proportion of a surface to a line, of an area to an ordinate, and whether species or numbers, though properly expressing quantities which are not homogeneous, may yet be said to express their proportion to each other. 32. Whether if all assignable circles may be squared, the circle is not, to all intents and purposes, squared as well as the parabola, or whether a parabolical area can in fact be measured more accurately than a circular. 33. Whether it would not be righter to approximate fairly than to endeavor at accuracy by sophisms. 34. Whether it would not be more decent to proceed by trials and inductions than to pretend to demonstrate by false principles. 35. Whether there be not a way of arriving at truth, although the principles are not scientific nor the reasoning just, and whether such a way ought to be called a knack or a science. 36. Whether there can be science of the conclusion, or there is not science of the principles, and whether a man can have science of the principles without understanding them, and therefore whether the mathematicians of the present age act like men of science in taking so much more pains to apply their principles than to understand them. 37. Whether the greatest genius wrestling with false principles may not be foiled, and whether accurate quadratures can be obtained without new postulata or assumptions, and if not, whether those which are intelligible and consistent ought not to be preferred to the contrary. 38. Whether tedious calculations in algebra and fluxions be the likeliest method to improve the mind, and whether men's being accustomed to reason altogether about mathematical signs and figures doth not make them at a loss how to reason without them. 39. Whether, whatever readiness analysts acquire in stating a problem or finding apt expressions for mathematical quantities, the same doth necessarily infer a proportionable ability in conceiving and expressing other matters. 40. Whether it not be a general case or rule, that one and the same coefficient dividing equal products gives equal quotients, and yet whether such coefficient can be interpreted by 0 or nothing, or whether anyone will say that if the equation 2 times 0 equals 5 times 0 be divided by 0, the quotients on both sides are equal. Whether therefore a case may not be general with respect to all quantities, and yet not extend to nothings, or include the case of nothing, and whether the bringing nothing under the notion of quantity may not have betrayed men into false reasoning. Whether in the most general reasonings about equalities and proportions, men may not demonstrate as well as in geometry, whether in such demonstrations they are not obliged to the same strict reasoning as in geometry, and whether such their reasonings are not deduced from the same axioms with those in geometry. Whether therefore algebra be not as truly a science as geometry. 42. Whether men may not reason in species as well as in words, whether the same rules of logic do not obtain in both cases, and whether we have not a right to expect and demand the same evidence in both. 43. Whether an algebraist, fluxionist, geometrician, or demonstrator of any kind can expect indulgence for obscure principles or incorrect reasonings, and whether an algebraical note or species can, at the end of a process, be interpreted in a sense which could not have been substituted for it at the beginning, or whether any particular supposition can come under a general case which doth not consist with the reasoning thereof. 44. Whether the difference between a mere computer and a man of science be not, that the one computes some principles clearly conceived, and by rules evidently demonstrated, whereas the other doth not. 45. Whether, although geometry be a science and algebra allowed to be a science, and the analytical a most excellent method, in the application nevertheless of the analysis to geometry, men may not have admitted false principles and wrong methods of reasoning. 46. Whether, although algebraical reasonings are admitted to be ever so just, when confined to signs or species as general representatives of quantity, you may not nevertheless fall into error, if, when you limit them to stand for particular things, you do not limit yourself to reason consistently with the nature of such particular things, and whether such error ought to be imputed to pure algebra. 47. Whether the view of modern mathematicians doth not rather seem to be the coming at an expression by artifice than the coming at science by demonstration. 48. Whether there be not sound metaphysics as well as unsound, sound as well as unsound logic, and whether the modern analytics may not be brought under one of these denominations, and which. 49. Whether there be not really a philosophia prima, a certain transcendental science superior to and more expensive than mathematics, which it might behoove our modern analysts rather than to learn than despise. 50. Whether ever since the recovery of mathematical learning there have not been perpetual disputes and controversies among the mathematicians, and whether this doth not disparage the evidence of their methods. 51. Whether anything but metaphysics and logic can open the eyes of mathematicians and extricate them out of their difficulties. 52. Whether upon the received principles a quantity can by any division or subdivision, though carried ever so far, be reduced to nothing. 53. Whether if the end of geometry be practice, and this practice be measuring, and we measure only assignable extensions, it will not follow that unlimited approximations completely answer the intention of geometry. 54. Whether the same things which are now done by infinites may not be done by infinite quantities, and whether this would not be a great relief to the imaginations and understandings of mathematical men. 56. 55. 55. Whether those philomathematical physicians, anatomists, and dealers in the animal economy who admit the doctrine of fluxions with an implicit faith can, with a good grace, insult other men for believing what they do not comprehend. 56. Whether the corpuscularian, experimental, and mathematical philosophy so much cultivated in the last age hath not too much engrossed men's attention, some part whereof it might have usefully employed. 57. Whether from this and other concurring causes, the minds of speculative men have not been borne downward to the debasing and stupefying of the higher faculties, and whether we may not hence account for that prevailing narrowness and bigotry among many who passed for men of science, their incapacity for things moral, intellectual, or theological, their proneness to measure all truths by sense and experience of animal life. 58. Whether it be really an effect of thinking that the same men admire the great author for his fluxions and deride him for his religion. 59. If certain philosophical virtuosi of the present age have no religion, whether it can be said to be for want of faith. 60. Whether it be not a juster way of reasoning to recommend points of faith from their effects than to demonstrate mathematical principles by their conclusions. 61. Whether it be not less exceptional to admit points above reason than contrary to reason. 62. Whether mysteries may not be better right be allowed of in divine faith than in human science. 63. Whether such mathematicians as cry out against mysteries have ever examined their own principles. 64. Whether mathematicians, who are so delicate in religious points, are strictly scrupulous in their own science, whether they do not submit to authority, take things upon trust, believe points inconceivable, whether they have not their mysteries, and what is more, their repugnancies and contradictions. 65. Whether it might not become men who are puzzled and perplexed about their own principles to judge warily, candidly, and modestly concerning other matters. 66. Whether the modern analytics do not furnish a strong argumentum ad hominem against the philo-mathematical infidels of these times. 67. Whether it follows from the above-mentioned remarks that accurate and just reasoning is the peculiar character of the present age, and whether the modern growth of infidelity can be ascribed to a distinction so truly valuable. Venus.